Hi, I'm back and we're going to talk about multi-area OSPF operation this time. Previously we talked about OSPF in general and how to configure and route OSPF. Good news is there isn't a whole lot extra to learn in the way of configuration. A few details as far as summarization that we'll get to in the second part. But in this first part, we're just going to talk about the multi-area OSPF concept and why we do it. And scaling OSPF. Now, already we know about OSPF in one area, and all of the traffic in one area, and all of the updates come into one area. So think about this as, you're flying down to, say, Seattle or somewhere with a big hub, and all the traffic and all the flights have to come and go into one area, and you have to hear all the announcements for every flight, and there's so much traffic going on, it's hard to even sort out what's yours and somebody else's. But if it's just a few flights, it's no big deal. But say you get 50 flights going on in one area, that can be a lot of noise, a lot of traffic, and very distracting. Well, it's the same thing, kind of, for routers. I mean, you get over 50 routers in one area, that's a lot of traffic. And every time there's a change, all the routers have to calculate their shortest path first algorithm, run that again, get the updates, get their databases together. And so imagine then if you're in Seattle and there's planes coming in from Asia and planes in from Europe, and you got to keep track of all their flights as well. It's just too much. So you break it in. Now, when I worked for the airline, we would just keep domestic traffic in one place, and we'd worry about the Asia schedule somewhere else. The European schedule was still another place. And you really didn't have to hear about it much unless you had somebody going between continents. And that was easy enough. You just had to send them to a gateway city. Well, that concept isn't so different here. Let's say that our network grows. You see we have here wide area network traffic mixed with non-broadcast multi-access inside an Ethernet. That's a lot of information that those networks don't need to know. So in this example, we break them up into different areas. And the Area 1 traffic here, it's not really that interested in what's going on in Area 51 and vice versa. But Area 0, the one we're used to configuring, is the backbone that works as sending information about the different areas between each other. So that simplifies things greatly as you scale and get bigger, and that's why OSPF is such a common, successful protocol. All right. Now, let's keep two terms straight, backbone and non-backbone area. Area 0 is the backbone. That's what we're used to configuring. And every OSP network has to have a backbone. So let me get out of the way here while we go on and talk some more about regular and backbone transit areas. All right. Let's take a look at types of routers. So we have internal routers. We have the, and as you see in the diagram here, every router that's in an area is an internal router to that area. Routers can have more than one tag here, by the way, so be ready for that. So it's pretty obvious the 4 routers in Area 51 are internal to Area 51, and the 4 routers, the 2 in Area 0 and the 4 in Area 1. They're connected independently. Okay. Now, a backbone router is just a router that's attached to Area 0. Now notice R1 and R2 are also attached to Area 1 and Area 51, but they're in area, part of them, one interface is in Area 0, and that makes it a backbone router. So on top of being a backbone router, they're also area border routers, all right, because they border Area 51 and 0, in Area 1 and 0. Now, the backbone is very essential. Every area has to attach to Area 0. Can't have anything coming through. You couldn't have Area 52 coming through Area 51 to Area 0. It wouldn't work that way. So the way OSPF is configured works when it scales is every area connects to the Area 0 backbone. And they do that via their area border routers, the one router that has an interface in each area. And R1 is even a little more hardworking because it's on top of all those other things, it's also attached to an autonomous system boundary router. The ASBR, say running EIGRP, or in this case the internet, so that comes in too. So there's different types of routers that make OSPF work. And what's happening in all of those different types of routers is they're using different types of LSAs, link state advertisements. And there's, a dozen or so advertisements out there, but we're focusing on the first 5 in this chapter because that's pretty much what we'll be dealing with in our routing tables. So the different types of LSAs that they're talking about occur from different types of routers in different areas. So let's try to keep this straight. It gets a little bit hectic, I know. So type 1 LSAs are within each area to the routers in that area. So all the routers in each area share type 1 LSAs, and that talks about directly connected networks, the ones that belong to them, the ones that you would type in an OSPF table, and link types, all right? So it's telling all the other routers who they are. I've got these networks connected, and these are the type of links I have. And all the routers generate type 1 LSAs, and they're flooded within their own area, but not outside that area. The boundary router is going to take care of the other areas. And here we go into LSAs type 2. These are the routers and network addresses of the multi-access links, just the multi-access, the ones connected by Ethernet. We see these over here in area 1's a multi-access network, and area 0 in this case is as well. So LSA type 2s are just the multi-access. And remember, the DR, the designated router, BDR, only the DRs share the information with LS2s. The other routers don't need to because they're not the DRs. So there's OSPF LSA type 3. The type 3 link state advertisement talks about networks learned by type 1 LSAs. As the routers are chatting with each other, the routers in area 2 learn about the networks on other areas. So they build a link database, and now they understand what subnets they know about, so they send those out. Now, the ABRs are the only ones that do type 3s, all right, because they touch another area. So ABR2 in this example takes link state type 3s from area 2 and sends them to area 0. And ABR1 sends them both ways between area 1 and area 0, etc. All right? And so area 1 would send it to 0 and then reintroduce that stuff into area 1. So the two routers here in area 0 are busy handling traffic between areas and letting the area autonomous system border routers know what's going on and where. All right? And then the type 4 LSRs take the ASBR to other areas and provide a route to the ASBR. So if there's something going on the outside, EIGRP or the web in this case, the ASBR sends in advertisements saying, hey, I have a route to the outside. That's a type 4 LSA. And that is generated by the originating ABR and regenerated by the other ABRs into the other areas. All right? And then the type 5 LSAs advertise external EIGRP type networks. All right? And we'll see those. Now we know what these LSAs are. We know that there's different types of LSAs, but what do they mean to us? How would we ever make sense of that? Well, the good news is, in the routing tables, that's where we see them. We have these codes up here in the top area of the IP routing table. Show IP route command generates it, and we have these type over here. The O for OSPF for type 1, OAI for summary LSAs, and OE1 and OE2. And here's what they look like. Here is a network learned from OSPF, and it's a code IA, and we go up here to O for OSPF, IA, OSPF inter-area. So we know that inter-area routes are in the table. So that's the show IP route. That's what we want to know. Am I getting my other area routes? In this case, yes. And what about the OE2? The E2, we come up and take a look. The E2 is OSPF external type 2. So we know that the type 2, we're getting a route to the outside, either the web or EIGRP route. But that is a route. In this case, it's a quad 0 IP route, a default route that heads out to the internet. So when we look at our routing table, when we look at the types of OSPF commands here, it tells us what kind of link state advertisements we're getting and what the function of those routers are along the way. That also works with IPv6. Show IPv6 route, and we have the same thing, the OE2 and the OI, for I is just the inter area here, okay? IA, I know IPv6 is a different one, so we have to go to OSPF and OSPF type 1, all right? So the codes look a little bit different here in IPv6. So the route calculation, all the routers are calculating routes, and all the areas calculate the shortest path to the best paths within their area and the best paths to other areas within the internetwork or inter-area network, and then all the best paths to the external autonomous systems. All right. So when it's opening the shortest path first, it knows the shortest path to all of those different ways to go. So that's the introduction to OSPF route calculation. In the second section, we'll talk about configuration and a little bit about summary. Thank you.